You know those cases, those real-life mysteries that just sort of get under your skin? Intriguing, but also deeply unsettling.
Absolutely. Some stories just stick with you.
Well, today we're doing a deep dive into one exactly like that. The mystery of the Gentleman of Heligoland. Back in July 1994, a body was found out in the North Sea near the German island of Heligoland.
And the details are quite striking, aren't they?
They really are. The man, estimated maybe 35 to 45 years old, possibly Australian, was unusually tall, like 6'5", and he was well-dressed, surprisingly so. A Marks and Spencer suit, Church's shoes.
Which seems quite specific for someone found in the sea.
Exactly. But here's the detail that's always stood out, the really disturbing part. He was weighed down with about 6 kilos of cast iron shoe lasts.
Shoe lasts. Those heavy forms they use to make shoes on. Yeah, that's grim. It immediately suggests something other than a simple accident.
Right. Foul play or something very planned. And that's what we're digging into today. Not just the facts, but a specific theory trying to reconstruct how he might have ended up there.
Using geographical data, I understand.
Yes, exactly. We're looking at a theory laid out in a KML file that's like a digital map file, you know. It plots locations, paths, that sort of thing. This one's called Gentleman of Heligoland theory.
Okay.
Our mission, really, is to unpack this theory, see what journey it proposes, and crucially, how ocean data, specifically from a GPS drifter, helps make sense of it all.
It's fascinating how modern tech and data analysis can shed light on these older cases, even without solving them completely. It offers new ways to look at the evidence.
Totally. So let's start the discovery, July 11th, 1994, near Heligoland. The KML file summary basically reiterates these facts, but it also makes a key inference based on those weights and, well, decomposition.
Ah, the timeline question.
Yeah.
Because of the weights, he wouldn't have surfaced immediately, right?
Right, that's the idea. The theory suggests he was likely submerged for maybe 3 days before the natural gases produced during decomposition would have made the body buoyant enough to float.
Which is a standard forensic principle in water recoveries.
Right, so if he was found on July 11th and surfaced maybe around July 4th, that pushes the time he actually entered the water back to roughly July 1st, 1994.
Okay, so about 10 days total in the water, give or take. 3 days submerged, 7 days floating.
Yeah, something like that. Now, the theory gets really specific about where it thinks he went into the water on that July 1st date.
Not just somewhere out at sea.
No, much more precise. It points to the Lauwersug ferry terminal in the Netherlands. The coordinates are right there in the file, 6.2 east, 53.41 north.
The Lauwersug. Okay, and the thinking is?
The speculation is he might have boarded a ferry there. The KML file even includes a route map for a ferry that runs between Lauwersug and the nearby island of Schiermonnikoog.
So on a ferry, and then into the water.
Yeah, the theory doesn't shy away from the grim possibilities, either pushed or jumped from that ferry around July 1st.
Which brings us to the big question.
How does a body starting near the Dutch coast end up floating near Heligoland off the German coast? It's quite a distance.
Currents, presumably.
Exactly, and this is where the KML file introduces the oceanographic data. There's a whole section on a North Sea drifter.
Ah, okay, so a drifter buoy.
Precisely. It's data from something called an ICBM drifter, which, despite the name, is just a type of GPS-tracked buoy. These are actually used quite a bit, especially in that area, the German Bight.
Right, they're part of experiments, aren't they? To track surface currents and sea drift very accurately, they use GPS and transmit their location via satellite.
Yeah, exactly that. And interestingly, these drifters are often designed to have a density or maybe interact with the water in a way that's kind of similar to how a human body might drift when floating.
Oh, that's a key point. So it's not just tracking water movement, but potentially mimicking how an object like a body would be carried by those surface currents.
That seems to be the relevance here. Now, this specific drifter data in the file, it's not from 1994. It was deployed much later, March 13th, 2017, and tracked until April 22nd that year.
Okay, so a big time gap. 23 years.
A huge gap. The KML file is upfront about this. The drifters started near 6.34 east, 53.78 north, and ended up near 8.78 east, 54.09 north.
Which way did it travel, generally?
Generally northeast. And that's the crucial part. The theory uses this 2017 data as an analog.
As a proxy for the likely current patterns back in 1994.
Exactly. Because while currents change daily, yearly, the general prevailing patterns in that part of the North Sea tend to be somewhat consistent over time, often flowing northeast.
That makes sense. It's not perfect. Obviously, weather in 1994 could have been very different day to day, but for a general direction over 10 days. It's a reasonable starting point for a theory. It shows that a northeastward drift is plausible.
Right. So the theory uses this idea to map out a potential drift path in two phases. First, the weighted period, July 1st to 4th.
When he was presumably on or near the seabed.
Yeah. The KML marks this with a green line. It shows really minimal movement from that ferry terminal area, just slightly offshore. The idea is he's weighed down, maybe only affected by weak bottom currents.
Less influenced by wind and surface drifts. Okay.
Then, around July 4th, decomposition gases likely make him buoyant. Phase 2 begins, floating and drifting.
And this is where the surface currents take over.
Precisely. The KML shows this with a red line, the approximated body drift path. And guess which way it goes?
Following the drifter's path, northeast.
You got it. It traces this arc, starting near Lauersug, heading northeast. The file plots several waypoints along this path, like past 6.78 east, 53.85 north, then near 7.1 east, 54.0 north, onwards.
Moving steadily towards Heligoland.
Yeah, heading towards 7.4 east, 54.05 north, and finally reaching the discovery location near Heligoland, marked around 7.65 east, 54.18 north, by July 11th.
So roughly 7 days of drifting on the surface, carried by those prevailing currents, matching the general direction shown by the 2017 drifter.
It lines up quite neatly, temporally, and geographically based on that analog data.
And it's explicitly an approximated path, acknowledging the uncertainties. Daily winds, specific tides in 94. Those would cause variations. But the overall trajectory seems plausible based on known oceanography.
The KML even includes another layer, a modified reverse drift path. Looks like they tried working backward from Heligoland for 9 days, ending up about 20 kilometers south. Suggests they did quite a bit of modeling.
Which adds some confidence. They weren't just drawing a simple line, they were exploring the possibilities using the available tools and data.
So let's just recap this theory. Man enters water near Lauersug, Netherlands, maybe from a ferry, around July 1st, 94.
Weighted down, suggesting foul play or suicide.
Sinks, stays submerged about 3 days, then becomes buoyant around July 4th.
And then drifts, carried by the prevailing North Sea surface currents, generally northeastward.
A journey similar in direction to what that 2017 GPS drifter showed, which, remember, was designed to track those surface currents and behave somewhat like a floating body.
Eventually arriving near Heligoland around July 11th, where he's discovered.
It all fits together geographically and temporally, using the drifter as a key piece of supporting evidence for the direction of travel. The KML file itself, with all its points and paths, it represents a really detailed effort.
And they do note, don't they, that this theory was assisted by AI, rejecting many other possibilities.
Yes, that disclaimer is in there. It emphasizes this is one theory, built using modeling, and acknowledging the 2017 data is just an analog.
Which is important. It's a well-reasoned theory, grounded in geographical data and oceanographic principles, especially the relevant behavior of the drifter, but it's still a theory. It doesn't identify him or say why this happened.
Absolutely. So while this KML file gives us a really plausible framework, a potential narrative for his final 10 days, the Gentleman of Heligoland himself, still unidentified.
The who and the why remain locked away. It's a stark reminder of the limits, even with clever analysis. We can map the currents, but not always the human story behind it.
It really leaves you thinking, though, here's this complex theory, using ferry routes, decomposition rates, and data from a scientific buoy deployed decades later.
Trying to trace the path of this unknown man.
Yeah, and just consider that for a moment, how these GPS drifters, these tools, designed purely to measure how the ocean moves, how water flows, how they can inadvertently become part of trying to understand something so profoundly human, so tragic, as a person's final journey across that same water.
It connects the cold, hard data of science with these deeply personal, unresolved human mysteries.
A strange intersection of oceanography and unsolved cases makes you wonder what other stories the sea currents might hold.